And we're back. Okay, so we're going to keep going to try a couple more of these. So you have to find the following, it says, without a calculator. So we have to use those reference triangles, our 30, 60, 90s, or 45, 45, 90s. So a negative angle is telling us we're going backwards. So I want to start here, my initial value. I want to rotate back, so here's 180, and another 30 would bring me up to here for 210. So notice I said and another 30. That means that reference angle is 30. And again, from our previous lesson, we had talked about the side opposite the 30 is 1, hypotenuse is 2, and the adjacent's the square root of 3. So if I want to find the sine of this angle, I use this reference triangle, and I say sine is opposite over hypotenuse. So this would give me a value of 1/2. And remember, all students take calculus, so in our second quadrant, our sign is positive. So the answer here is 1/2. Tangent of 5 pi over 3. Okay, so it's a positive angle. So 5 pi over 3, well, 6 pi over 3 would be a total of 2 pi. So this is 1 pi over 3 less, meaning it's got to be down here. Pi over 3 I know is going to be 60 degrees. So again, if I'm trying to think, so what angle is this making? So this is going to leave me with the 60-degree reference angle. So opposite the 60, radical 3, hypotenuse is 2, our other side is 1. And if I'm looking for tangent, I'm thinking tangent is opposite over adjacent. So that's going to give me square root of 3. But now again, keep in mind, all students take calculus. In our fourth quadrant, only cosine is positive, so that means our answer has to be negative. Okay. 3 pi over 4. And again, if these radians are still a little difficult, then I would say transfer them into degrees, and then from there, do the work. So 3 pi over 4, that would get us a negative 135. So if I were to graph that, a negative 135 would put me back here, right? So here's our initial side, our terminal side. And what that's doing is that's going to give us our reference angle again of 45. So 1, square root of 2. So secant's the reciprocal of cosine. So we know that cosine is adjacent over hypotenuse. I'm looking for this guy to be hypotenuse over adjacent. So my hypotenuse is the square root of 2, and the adjacent side is 1. Then again, all students take, so only in this section, tangent and cotangent are positive, which means this answer has to be negative. Okay. So then we come up to things called quadrantal angles. Quadrantal angles are just angles on an axis. And probably the easiest way that we could do is we're going to pick a point along one of the axes, and we're going to get coordinates that go with it. And again, if we're referencing this back to a unit circle, it's always easier to just stick with a unit circle of 1, making your coordinates perhaps, like say over here, I would call this 1, 0. Or for a negative 270, now again I'm going backwards, so here's 90, 180, 270. The coordinate that would go here with 270 would be 0, 1. And again, a little review from your Algebra 2 days. Your coordinate, your x-coordinate always went with cosine, the y-coordinate always went with sine. So same thing, cosine, sine. So if I'm trying to find cosine, sine of negative 270, well, here we go, we found it, it's a 1. Okay. Tangent of 3 pi. So one full rotation I know is 2 pi. So that means I have to do a full rotation and an extra half. So I hit full rotation and an extra half. So that's putting me over to here on the axis. So our unit circle coordinate, we have a negative 1, 0. And now I want tangent. Well, tangent is made up of sine over cosine. So I know it goes cosine, comma sine. So I'm going to take my values and go sine over cosine, which is going to give me a value of 0. And for this last one, secant of 11 pi over 2. 11 pi over 2 is a value, pi over 2 is a value of 90 degrees. So I need 11 90s. So So here we go. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 90s. That brings me right down to here. And my coordinate, again, unit circle, I would think 0, negative 1. I would think cosine, comma, sine. So I need the secant of this. So the secant is the reciprocal of cosine. Well, cosine right now is 0, or I could think of cosine as being, say, 0 over some number. So the reciprocal of that then would get me some number over 0. Well, anything over 0 is undefined. Okay, so moving on, we have a couple more problems. So it says find cosine and tangent. So at the very end, I have to come up with these two ratios. And it says by using this given information. So things we have to consider is where is it located? So going back to our all students take calculus, we got to keep that in mind because now I have a plate, it's saying sine is positive. Well, sine is positive in both our first and our second quadrant. Tangent being less than 0, meaning tangent is negative, well, that only happens in our second and our fourth quadrant. So I see that they have common the second quadrant. What that means then is the reference triangle that we're going to draw is in our second quadrant. So here's our reference triangle. Keep in mind what that's saying. My initial angle's here, my terminal side's over here. This is really the angle that we're dealing with, but I'm going to use that as my reference angle. Okay, so sine we know is opposite over hypotenuse. And if I want to find this third side, I'm going to do Pythagorean theorem. So I have 3 squared plus x squared equals 7 squared. And if we solve that, we're going to see that this third side turns out to be the square root of 40. So now I need to find cosine. So our cosine, first off, it's in the second quadrant, so I know it's got to be negative. Cosine is adjacent over hypotenuse, so I would have the square root of 40 over 7. We have to find tangent. So the tangent of this angle is opposite over adjacent, but now keep in mind, second quadrant, tangent is also negative. If we try another one, letter B, so secant. Secant, it goes with cosine. So cosine is positive in our first and our fourth quadrants. Sine that's saying is positive, so sine is positive in our first and our second quadrants. So that's telling us, again, when we draw this triangle, I know that this has to be located in our first quadrant. Okay, so if secant's the reciprocal of cosine, and I know cosine is adjacent over hypotenuse, that means right now I have hypotenuse over adjacent. So my hypotenuse is 3, my adjacent side is 1. And again, I'm going to do Pythagorean theorem to find my missing side. So my missing side, once we do that, will be the square root of 8. So again, we are on the lookout for cosine and tangent. And the nice thing with being in quadrant 1 is everything is positive. So our cosine is adjacent over hypotenuse. Tangent we have is opposite over adjacent. So that would just be square root of 8, or you could put square root of 8 over 1. Our next one is going to be a little thought-provoking. So we know cotangent is undefined. Cotangent, if I were to think of the ratio of cotangent, I know it's the reciprocal of tangent. Tangent's opposite over adjacent, so this has to be adjacent over opposite. We also know that tangent is defined as sine over cosine, so this would be considered cosine over sine. And if this were to be something that's undefined, that means sine has to be 0.
Please have your attention.
So with sine being 0, what that's telling us is that's got to be on an axis. It's got to be a quadrantal angle. Sine being the y value of our coordinate, that gives us two options. So it looks like it's either going to be here at -1, 0, or it's going to be here at +1, 0. Now the other thing that we have to think about is secant theta is negative. which means its reciprocal cosine theta is negative. So if I'm looking at that, cosine being the x-coordinate, that means our answer over here has to be at this location. So if we were to answer what is the value of cosine, so cosine has to be -1. And the value of tangent, well, tangent we know is sine divided by cosine. So if I took our sine divided by our cosine, that's going to get us 0. And then we have two other questions, just kind of more application questions involving trig and doing things with angles of elevation, angles of depression. Your angle of elevation, I always think is what you're looking up. You're looking normal line of sight and you want to tilt your head up or see something above. Angle of depression, you take your normal line of sight and you want to look down. So a lot of times like you're on a cliff and you're looking down at a boat, or you're at a tower and you're looking down at some cars. So two basic questions here. So you have the angle of depression of a buoy from the top of a lighthouse. So here's our lighthouse. We got some person standing at the top of the lighthouse. Here's their normal line of sight. Because it's an angle of depression, now they have to look down, and they're taking a look at this buoy, and it says it's 6 degrees. So notice where that 6 degrees goes. Okay, it says we have to find the distance from the base of the lighthouse, which is here, to the buoy. So they're saying find this. We know the lighthouse is 130 feet, and I have to find this distance. If you go back to your days of geometry, this angle of depression and this bottom angle of the triangle are alternate interior angles, so they're equal. So what that does is that puts that angle of depression into your triangle, and now you can just do some basic trig and say 30 is going to be our opposite side, x is going to be our adjacent side, and that's going to allow us to use the tangent ratio. So I can say tangent of 6 is equal to 130 over x. And if we multiply, I can see x times tangent of 6 is equal to 130. And to solve for x, we divide through by tangent of 6. And we can find x is going to be 1,236.87 feet. Please keep in mind this is in degrees. Your calculator should also be in degrees too. That's something that you want to check for. And our last one, the angle of elevation. So we have the angle of elevation up to the top of a cathedral from a point 300 feet away. All right, so we have to think cathedrals, hopefully buildings are nice and vertical. And I'm looking to the top of this. So that means I'm standing on the ground somewhere over here. I'm looking to the top of the cathedral. And it tells me I am about 300 feet away from the base. So I know that this has to be 300 feet away. And it's telling me that angle that I'm looking up is 60 degrees. So here I am standing down here, looking up at the top of the cathedral, and my angle of elevation, that change of my eyesight, is 60 degrees. And we have to find the height of the cathedral. Okay, so again, it looks like here's my opposite side, here's my adjacent side. So again, we're going to be using that tangent ratio. So we have the tangent of 60 is equal to our opposite over adjacent. And if we cross multiply, that gets us 300 times tangent of 60 equals x, and you can just plug that in your calculator. Again, should be in degrees. And we're going to see x is going to be 519.62 feet. So hopefully some of your Algebra 2 is coming back. Again, we'll practice this in class, but I'm hoping this gave you at least a foundation, and if for nothing else, something that you can go back and watch again if you get lost in class. Okay, don't forget to like and subscribe. Have a great day.